Yes. So we continue with hyperbola. In this case, we did go through circle very briefly, parabola, and then ellipsis. So today we will talk about the last conic section, which is the hyperbola. So please, you do not need to memorize the formula, but there are some formulas you need to add on to it, especially finding the C, the distance from the vertex to the foci. So we're going to continue with, let's see if I have my share screen. No, I haven't shared my screen yet. So we're going to continue with our hyperbola here. So as I mentioned again, you do not need to memorize the formula because I provide the whole this 4.4 formula for you guys. So make sure you guys know the rate ones, which is what is the ABC stands for, how do you find the C, which is the distance from the center focus point for ellipse, is given us by C squared equals to A squared minus B squared. So make sure you know this is a minus one. And then you will see what happens to the hyperbola case. So we'll talk about that in today's class. So the hyperbola. So a hyperbola is like a parabola, but this usually it will have two. So either you both open outwards and downwards, or open sideways left and right. So hyperbola has two. So what is the definitions of hyperbola? So hyperbola is where you have all the points x, y in the plane that the absolute value of the difference between the distance of the two distant fixed point is foci is the same. So if you remember, for ellipses, we use the sum. That means you add the two distance and they are the same. But for the hyperbolas, is the difference. And since when you do the difference, sometimes you get a negative value, sometimes you get positive values. So what they do is they take the absolute value of it. So that means your value is always positive. So you find the difference of the absolute value of the difference here, of the distance between these the points and the foci, and it is constant. Constant is the same. So I will show it to you what it looks like in the picture. So it's it's nicer. So this is what a hyperbola is. We call this as your branch. So it can be going up downwards or doing sideways. And we have a focus point, foci. So we've got two. One is inside the first one, and second one is inside. So usually the focus point is always inside the branch, like a parabola. And then so if you find the distance between a point with the focus point and a point with the other focus point, and the distance, if you subtract this and take the absolute value, it is going to be the same doing any points on here. So if you take a point right here and you find the distance between this point with this focus point and the distance from this point to the focus point, and you take the distance and you subtract them and you take the absolute value, the distance is the same throughout any points. So this is the meaning of the hyperbola in this case. So this is also telling you what is a transverse x. So if you cannot hear me, let me know, because I have a little thing pop up here saying that my no system resources. Okay. So what we call this line is a transverse axis. So transverse axis is where your center, your vertex, and your foci or your focus points are on the same line. So if they're on the same line, we call this as your transverse axis. It's different from your ellipses. So if I go back to ellipses, we call that as your major axis in the ellipse. So in ellipse, if you have your center, your focus, and your vertex on the one same line, we call it as a major axis. And if you look at your ellipses, your focus point come in between your center and your vertex, right? So your focus is right here. But if you look at your hyperbola, it's a little bit different because center first, and then vertex, and then focus. So that is a little bit different from the ellipse. The ellipse, the vertex and the focus actually been switched around. It means the vertex is on the outside, the focus is inside. But for a hyperbola, it's switched around. And again, A is the distance from the center to the vertex. C is the center, the distance between the center and the focus point. So it's very similar to what we have on the ABC that you guys did here. So A is the distance center, distance from the center to the vertex to the focus point. But B in this case is special. So we will talk about what is B here. So B in this case is not the distance from center to the minor, because hyperbola does not have a major minor axis. It only have a transverse axis. So just want to point out to you guys what is the difference here. The equation, so right down here, that's the equation. So you have the equation here. So the equation of a hyperbola is given us by x squared minus y squared, or x squared over a squared minus y squared over b squared equals to 1, or y squared over a squared minus x squared over b squared equals to 1. So I always tell my students what variable comes first for the what variable is positive. So if you compare between ellipse and the hyperbola, ellipse, they both of them they're plus. So x variable is positive, y variable is positive. But for a hyperbola, the positive one is the one that tells us which one the transverse axis is. So if you see here, this is x is a positive one, and you know x is the one that goes, the x-axis that go horizontal. So that's why the transverse axis is in horizontal. And if your y square is a positive value, y is going up and down, so it's a vertical. So that means your transverse axis is vertical. And don't forget, when I say the transverse axis, means your center, your vertices, and your foci all in one line. Okay. So usually when you have a horizontal transverse axis, this will open sideways. This will open sideways. So your branches will be open sideways like this. This is where you have a horizontal. When you have a vertical one, then it will open up and down. Okay. So like as I showed you a picture here. So this is the one. So if you have an x squared that is positive, it will open sideways. And if your y square is a positive, then it will open up and down. Your transverse axis will go on the x-axis. That means your center will be in the middle. Your vertices and your foci is all in one line on the x-axis. And for the y square one, the positive one, everything is on the y. The transverse is on the y. So that's how I cause students to do it. Now, in order for you guys to find out what is C in this case, we have a formula in this case. So to find what is the distance from the center to the foci, the formula is C squared equals to A squared plus B squared. So it's a little bit different from the ellipse, because ellipse is C squared equals to A squared minus B squared. So this is a little bit different from the ellipses, because it's no longer minus, it's plus. So it's actually exactly the same as the Pythagorean theorem, a squared plus b squared. C squared, that is your hyperbola. So a lot of students get these two mixed up. So if you get these two mixed up, then your C will be wrong. Okay. Moreover, if you remember in the ellipse, I always say that which one is your A, which one is your B. I say who is bigger, right? The A in this, so in this case, I always say A is always bigger than B. So for ellipses, for hyperbola, it does not say anything about A is greater than B. As long as your A and B is positive, that's it. So in hyperbola, it doesn't say that your A has to be greater than B. No. Okay. So this is the one that I want to point out here. In ellipse, yes, A must be greater than B. Yes. Okay. And for the hyperbola means no, it's not necessary. So if you notice that always the positive one is A squared, the negative one is B squared, depends on where your X and Y is. But this one, make sure you know that your A is the bigger one will be always the X, or the bigger one will be Y, depends on where you put it for the ellipse. So that is the difference between ellipses and hyperbola. So make sure you guys know this. This is quite important here. A lot of students get this confused and say, oh, this A has to be greater than B, like ellipse. it doesn't state that. Okay. Because of when you draw me the hyperbola, it does have asymptotes. So asymptotes will be this line. So if you look at this pink dashed line, that is your asymptotes. Okay, that will be your asymptotes. When you want to graph a hyperbola, asymptotes is important. Okay, asymptote is very important because the asymptote will determine how narrow your hyperbola is or how wide the hyperbola is. So if this x, the asymptote is always an x, and if this x is a little bit closer like this, then if you go sideways, it's going to be very narrow. So make sure you guys know that every time when you draw me a hyperbola, you have to draw me the asymptotes. How do you find the asymptotes? We have a formula also. So the asymptotes for a hyperbola in this case is given us by y equals to plus minus b over ax and y equals to plus minus a over bx. The b plus minus b over ax is for horizontal, and the a over b is for vertical. So because we have two types of hyperbola here. So again, how do I tell my students to do this? Because I hate to cause students to memorize all these formulas. I want to tell you that because this is a horizontal. So when you look at your horizontal, it's this fellow. Now, if you remember, this b over a and ab over b is your slope, right? This is your slope, right? Mx, right? Y equals to mx. The reason why there is a plus minus in there is because plus means your slope goes up. So that means that you will get one of the line that the slope goes up, and the minus means the slope goes down. So that's why you got plus minus, because you got two asymptotes here. So the slope is positive, it's go up, the slope that negative goes down. Okay, so how do you figure out which one is it? Is that b over a or a over b? Then you need to know that m in this case is a slope. And if you remember the formula for slope, slope is the difference of y over difference of x, right? So if you remember the slope is you take the change of y over the change of x. So if you look at this horizontal formula here, for the hyperbola, you find out that the y underneath is b and the x is a. So that means if you look at the slope formula says y over x. So that's why this is b over a. You see that? Because this is b over a. If you do the vertical one, your y is a in this case and your x is b. So in this case, it's a over b. So this is how I tell my students how you figure out your slope for your asymptotes, is looking at your equation and looking what number is below the y and what number is below the x, and that you just take that divide that number over the y over x numbers in this case. Make sure you take the square root of it, because this formula is b squared and a squared. The slope is no square involved here. Okay, so if you look at the formula in the then now we talk about b. Okay, because we talk about a, which is the distance from the a is a distance from the center to the vertex. C is a distance from the center to the foci. B in this case, if you look at this, is the distance from the center to the maximum of the height in this case. So this B is used to draw your asymptotes. So let's say that your A is 3 and your B is 5. Again, it's not necessary A has to be greater than B. So it can be this case. So what happens is, let's say that this, you figure out this is your it is the open sideways. So what do you do here is you do A is 3 and B is -3. So this is your vertex. Okay, so that means that this fellow will be at -3 and this fellow will be at 3. And now we're going to figure out B is 5. So this is your 5 and this is -5. So now we need to draw your asymptote in order for us to draw this hyperbola. So what you do here is you draw me a box. This box will have up to 5 here, and then down to 3, and then down to -5, and down up. So this is the box you draw. And then the asymptotes is always connect from one end of the box to the center and to the end of the other side. So this is your first asymptotes, which will be the negative ones, is the slope is going down. And then the other one is joining from one end to another. So this is how you draw the asymptotes for a hyperbola, which is very important. And then what you do now is, since you have a vertex here, so your hyperbola will be look something like this. So that's the reason why that the asymptotes, the blue line that I draw here, is very important. It determines how wide and how narrow your hyperbola is. So some students did not draw the asymptote. They just simply, oh, this is open sideways, so they just simply draw like this. You won't get full points in my test. So I do want to see this box, the green box, and which is a dashed line, and I want to see the asymptotes, the blue line, and then you begin to draw your hyperbola in this case. So this is the correct way to do it. In your test, this is wrong way. So don't just simply draw me, two parabolas, open upwards or sideways, upward, downwards or sideways. You won't get full points in your test. You guys clear with me here? Okay. If you look at your formula that I provide to you, if you look at this formula, it doesn't say anything about all this. Just give you these two formulas. Okay. So again, I'm going to copy and paste over here. It doesn't let me to copy and paste. So you will have the same stuff here. Oh no. Oh no, I don't know where it went. So A in this case will be the distance from the center to the vertex. Okay. B in this case is this distance from the center to the we call it the height of the box. Okay, that means how the height of it. So A is on that side, or A is this side, then B is on that side, and then C is the distance from the foci. So this is not in the in your formula, so make sure you know that. You know, where is this one went? And to find the focus point, as what you see over here, you use C squared equals to A squared plus B squared. So this is the formula for to find your focus point here. Instead of minus, this is a plus. And now I need to tell you about your asymptotes. So in order for you to find your asymptote in this case, your asymptote in this case will be y equals to, so what you do here, if it's horizontal, this is your y, this is your x. So it's going to be plus minus, y is b, x is a, so it will be b over ax. Okay. For the asymptote for this case, you just, if you know one, then the other one, you just simply flip-flop it. Plus minus, or you can look at here, this is a, y is a, and x is b, so it will be a over bx. Okay. So this is your asymptotes in this case, and then we'll talk about more when we have transformation of it. You guys all right here? Anyone have any questions with? So these are stuff that is not in your formula here. So make sure you make sure you add, when you guys got my task, make sure you add all this little formula, especially with the how you find your focus point. Okay, just to bring it up. All right. So it's right here actually. I don't know why it moved down up there. There is something wrong with my. I think it's because I used too much of my memory. So anyway, so let's take a look at some questions here. So again, question 7 is asking us to find the equations of a hyperbola. So if a question asks us to find the equation, means that either you give me horizontal one or vertical one. And like ellipses, in order for you to figure out if they're horizontal or vertical, make sure that which line they line up with. If they all line up on the x-axis, which is the horizontal, then it will be the horizontal one. If it's lying on the y-axis, will be vertical one. So go ahead. Let's take a look at 7a here. So I will Not going to save this because you'll learn how to draw that. So question 7a is asking us, so it's a hyperbola with the center's origin, given us that the vertices is going to be plus minus 1, 0. And asymptotes is y equals to plus minus 3x. Okay. So the first thing you need to do, class, is to, because the center is at 0, 0, kind of draw this follow-up. So every time, this is my thing for you guys. If a question give us to find the equation, I would strongly for you kind of sketch this follow-up, although the question doesn't ask for it. It will help you to figure out, are these a horizontal one or are these a vertical one? This is the first thing you need to do. So the center is at 0, 0. The vertex will be at negative 1, 0, and 1, 0. So is this transverse axis on the y-axis or the transverse axis on the x-axis? Anyone? What is the transverse axis for axis for this case? Y or x?
Is it X?
Yep. So the transverse axis here is on the x-axis, and x-axis, is that horizontal or vertical? Which one?
Horizontal.
This is horizontal. Yep. So now we can use the formula. So the formula for this case is hyperbola transverse axis on the horizontal. We use this. Again, your HK is 0, 0 because your center is at 0, 0. Your formula will be x squared over by a squared. This is your equation. Minus y squared over b squared equals to 1. So this is your equation in this case. So as you know that a is a distance from the center to the vertices. So we know a in this case is 1. Okay, now we need to figure out b. So what determines b? We got to use your asymptotes here. So if you know the formula for asymptotes, y equals to plus minus x. So now you need to figure out, are they a over b or b over a by looking at this formula? Can someone tell me, is this a over b or b over a?
B over A.
Because the y is on top, right? So b over a. And if you compare this with the formula of y equals to plus minus 3x, that means that this 3 has to be b over a. So with this, you're comparing this. So we figure out that b over a has to be 3. And moreover, because we got no a is 1. So this is 1. So we can solve for b. So anyone know what is b in this case? So exactly.
Is it 3?
3, yeah. Because 3 over 1 is 3. So now we got a and b. You didn't figure out c because the equation doesn't involve c. So you just need a and b. So plug all this back into this equation and you get yourself your answer. So your answer in this case for the equation is x squared over 1, which is a squared, minus y squared over b squared. 3 squared is 9 equals to 1. So this is your answer for question 7a. And as usual, if you want to, you can erase the over 1 because over 1 is redundant. Or if you want to put over 1, I am fine with it. So this is how you do question 7a. Okay, so first draw the kind up, figure out is that a horizontal or vertical by the sketch that you draw, and then give me the formula, and usually you need to figure out a and b. So let's take a look at question b here. It's that question b right here. So this one is given us that the foci is 0 plus minus 8, and the asymptotes is y equals to plus minus 4x. So this is, and we need the equation. So as usual, I want you guys to draw, kind of sketch this fellow out. And again, the center is at 0, 0. And tell me, what is your transverse axis at? Is that on the X or the Y axis? Or in other words, horizontal or vertical? Okay, your foci or your vertices will tell you that. Anyone?
Y-axis.
So 8 is right. This is your foci, right?
Yeah.
Which is 8 and negative 8. So is that gonna be on this y-axis? So it's gonna be what? Vertical or horizontal on the y-axis? This is considered vertical, right? So the formula we use is just, if it's vertical, it's kind of the same as this. You just switch your y and x around. So it'll be y squared over a squared minus x squared over b squared equals to 1. So the good news is we know the distance of the foci. What is that symbolized? A, B, or C? The distance from the center to the foci, we know is 8.
It's,
I'm sorry, Gamal?
I was going to say it's C.
Yeah, it's C. So we know that C in this case is 8. But your formula doesn't need C. Your formula needs A and B. So what we need to do is we have to use your asymptotes again. So remember last time the asymptote is B over A because you have a, so anyone know what is the asymptotes in this case? B over A or A over BX? Again, look at the formula, it will tell you.
It's A over B.
So A over B. So in other words that if you compare your asymptotes with this formula, we also got another one where A over B in this case is 4. Now last time is easy because you know A. Unfortunately, we do not know A, we do not know B, we only know C. So you have to figure out A and B here because that's what the formula needs. So you have to use some substitutions. So you have to use another formula for C because since that is another formula that use foci, and that formula is that A squared, the Pythagorean. So C squared equals to A squared. C squared is equals to A squared plus B squared. So unfortunately, this kind of questions is a little bit difficult because you have to use substitution in this case. And we know C is 8, so 8 squared is 64. But unfortunately, we do not know A and B. But we know using this, so we will use substitution here. So what we do here is I multiply B on both sides. So in this case, we know A in this case is 4B. And what do I do is I take this and I substitute back into this A here. So we kind of using like solving system of equations here where we got 2 equations and I have 2 variables A and B. We try to figure out what is going on here. So we use substitution. So in this case, our A in this case is 4B. And so when you square this, this will become 16B. So this is 64. This will become 16B squared. And then you have add 1B squared. So we got 17B squared. Okay, so this is 4 times 4 is 16, and then you add another one, 17. So we have to solve for B, so we divide both sides by 17. So we found out that B squared in this case is 64 over 17, which is good. We just found B squared, which is him. 64 over 17. But we do not know A squared. So what we need to do here is we have to use substitution, substitute back. But since this is a b square, this is just only b. So what do is I square both sides here. So we'll end up with a b square. So what we have in this case is a square, in this case is 16 times b square. And since we know b square is 64 over 17, I resubstitute this back into our b square. So it's 16 times 64 over 17. Calculator here. What is 16 times 64? 16 times 64. This is a big number. So it's 1024 over 17. So this is my a square. So now we found a square to become this icky number, 1024 over 17. So what you do now is you get your answer here because you just need to resubstitute back. So y squared over by this icky number, 1024 over 17, minus x squared over by a b squared is this number, 64 over 17, and this is equals to 1. So this is your answer for question B. Yeah, it's a little bit tough. So if a question only provide you the foci but not the vertices, like what we did in 7a, is a little bit more work. You can leave your answer like this, or otherwise you can move this 17 to the top. So this is your answer here. Or if you want, you can move the 17 on top. So you become 17y squared over by 1024 minus 17x squared over by 64 equals to 1. So this is also your answer here. So no matter, I'm not picky. So there are two answers here. You can write it in this one or this one, same thing in your test. I am not picky which one you write. As long as you know how you found the a squared, b squared using substitution here, that will be your answer in this case. Anyone have any questions for me here for question 7? Anyone? This is 4.3. All right, so next so this is how you find your equation. So make sure you guys know the word is called find the standard form of the equations of a hyperbola. Okay. So the next one we're going to talk about here is number 8. So number 8, you have to find the vertices of the hyperbola and you have to sketch it using the asymptote as an 8. So that means you need to draw me the x line, the box, and then draw me the hyperbola. So what we have in this case is 4y squared minus 9x squared equals to 36. So the first thing I want to point out to you guys is no matter it's an ellipsis or hyperbola, they're always equals to 1 on the side. Okay, so what do we do here? If you have this, you divide both sides by 36. So now you get 1 here. Now you can reduce this. So this is y squared. Can someone reduce what is 4 over 36?
1 over 9.
1 over 9. So 1 over 9. And again, that one is, you can erase. Okay, or you can leave it there. It's up to you. How about the next one? 9 over 36. Can someone reduce the x one? 9 over 36?
1/4.
1/4. So again, the 1 up here you can erase. So this is the equations of the hyperbola that you have. So the question is asking is this a vertical one or is that a horizontal one?
Vertical.
Because why you say it's vertical, Gama?
Because the y squared comes first.
Yeah, the y squared is positive. Okay, so sometimes it's tricky. I want to point out to you. Sometimes it can be like this. I just want to point out for those who sometimes it can be tricky like this. That means I switch your x and y around and become like this. And a lot of people say, oh yeah, x come first, so this will be a horizontal. This is wrong. This is the same as vertical. Just want to point out to you, don't look at who come first for hyperbola. Look at who is the positive one. So if your y square is a positive one, it's a vertical. If your x square is the positive one, it's horizontal. So I just want to point out to you because your homework questions and my test sometimes can be tricky like this, and a lot of people think who come first or that will be your vertical horizontal. So be careful with that. So since since your y square is positive, means your 9 here is your a square, and your 4 in this case is your b square. Okay, so because the vertical says this is a square and b square. So can someone tell me what is a and b in this case? A is, you have to take a square root of it.
Is plus minus 3, b is plus minus 2.
Now, this question is asking us for the vertices. If I talk about vertices, are we using A, B, or C? A, B, or C? Which one is the one that for vertex?
A.
A. So your vertices in this case is A. And here is the question. Where should we put the plus minus 3? Is that 0 plus minus 3 like this? Or is it plus minus 3, 0? So plus minus 3 is A, that's correct. So which one is this?
Top one.
Again, this is, you say it's vertical, right?
Mhm.
When you say vertical means what? All the points has to be on the y-axis, or all the points have to be x-axis? For vertical, which is
If they're
vertical?
on the y-axis.
Y-axis, and if it's all y-axis, so your A in this case has to be 3 and minus 3, right? So can someone tell me what coordinates is this one and the coordinates of this one? Is that 0 plus minus 3 or plus minus 3, 0?
0 plus minus 3.
Yep, this is the correct one. This is wrong. So be careful with, I know you know how to find A, but then make sure you know where you put it. Is it on the X value or the Y value? So this is the coordinates of the vertex. Now we need to draw. So how do we draw this? I'm going to draw a better one because this is just a sketch. So, so the picture, so we found the vertices, which is the question, and then you have to sketch it using your asymptotes. So the center is at 0, 0. The vertices is at 3 and minus 3. So can someone tell me, is this hyperbola is open upward, downward, or sideways? Is it open upward, downward, or sideways? Which one? Look at your vertex. The vertex will tell you. Anyone? Which one is this one looks like? This A or B?
Upward, downward.
Yep, because your vertices is on the y-axis. So for any vertical one, your hyperbola is open upward, downward. For the horizontal one, it opens sideways. So this is your A, and now we found out B is 2, right? So B is plus minus 2. This is your B. And as you know that at the beginning of when we talk about hyperbola, you need to draw me that little box. So this is your box. And yes, you have graph paper, it's easy for you to draw the box. And then your asymptotes is crossed from one end to another end, purple line. So from here to the center to the other one. So this is the one of your asymptotes. And the other side, one end to another end is your asymptotes. So now this asymptote will guide us how narrow, how wide it is. So since you say it's up and down, so your hyperbola in this case will go up, and it never touch or never cross your hyperbola, your ellipse, your asymptotes. Same thing here, it never cross on it, so it's go kind of like parallel to it, like your rational functions we did. So the red line that you draw here is your graph for number 8. You guys all right here? Questions? Anyone? So yes, you do. But the question did not ask us to find the equations of the asymptotes. But if a question wants you, this is extra. Okay, this is extra. What is the equation of the asymptote? If the question wants you to find. Y equals to plus minus something actual. What is this going to be? Is that 3/2 or 2/3?
3/2.
Because it's y here, so which is the one underneath y, so it's 3/2. This is correct. Now again, I think you guys know on your online homework they don't like to use plus and minuses, so you have to write this 2 times. One is y equals to 3/2x and y equals to negative 3/2x. So in your online homework, if they ask for a asymptote like this case, don't use plus minus what I did over here. They will mark you wrong, although it's correct, because they don't like plus and minuses. Okay, in my test, sure, be my guess.
Is the asymptotes just the dimensions of this box?
No, asymptote is the orange, not the orange, the purple one. The purple line.
Oh no, I'm talking about like the equation for the asymptotes. It's 3/2 almost.
It's based on your A and B.
Okay. All right.
That's like the slope of the asymptote, right?
Yeah, it's a slope. Yep. So this is actually a slope.
Okay.
And it depends on your A and B. And if you look at here, the slope in this case is going up 3/2. You see that? 3/2. So that's why it's 3/2. And then this one go down 3/2, negative 3/2. So you got a negative. So you can also use the box, the box to help you to find the slope, which is the 3/2 in this case. So no matter what you do, I'm fine with it. So I'm, as long as you get the correct answer, I'm happy. Questions? Okay. Next is number 9A. Question 9 is asking us, is this true or false? You have to tell me, if you just say true, you cannot just say true or false. If it's true, then yes, y is true. False, y is false. Okay. It says that the equation x squared minus y squared equals to 144 is represented by is a circle. Is this true or false? And you'll explain why. Anyone? True or false if this is a circle? Yeah. Anyone? Anyone remember what is the equations of a circle looks like? Anyone know what the equation of a circle looks like? Circles. Circle's equation is x squared plus or minus here. It's a plus y squared equals r squared. So in this case, is this a circle?
No.
No, this is false. Yep. And the reason why this is false is because this is a negative. So x should be x squared plus y squared equals to 144. So this is a circle. But if you want to use the minus, then it is what? So which one is give us a minus sign? Circles, parabola, ellipse, or hyperbola?
Hyperbola.
Yes, this is a hyperbola. And remember last time when you draw me the box, this is 2 and this is 3. Since this is 144, which if you divide this, you get 144 each. So it is actually a hyperbola with the box of 12, 12. So when you draw me the box in this case will be measure 12, negative 12 to 12 on both ends. The reason why you get 12 by 12 here is because 144 perfect square is 12, 12. So this is a hyperbola. You guys with me here? And this is open sideways like this. So this is where, again, I'm just kind of draw, again, very sketchy drawing. Next, question B is asking us, is 9B, the major axis of this ellipse is vertical. So y squared plus 16x squared equals to 64 is an ellipse with major axis is vertical. Vertical means it goes up and down. So how can you figure out, is it true or false? So how do you figure out if this is it's an ellipse for sure? And how do we know it's an ellipse? It's because they are plus and they have x and y. So how do we know your major axis is vertical? Is your y value, it looks something like this. That means your A has to be greater than B. So what do you do with this is you have to make this equals to 1. So I will divide. So I didn't know this. So this is my explanation here. So I have to divide this by 64 to check. So I will divide this by 64. So I will get y squared over 64 plus 16x squared over 64 equals to 1. Now this one we cannot reduce because it's already reduced. Can someone reduce 16 and 64? Anyone know how to reduce that?
Is that 1/4? Is that 1/4?
It's 1/4. Yep. So this 1/4. So in this case, that which one is bigger? 64 or 4?
64.
So we know that this is your A square and this is your B square, right? Okay. So is this having a major axis is vertical? True or false? Again, how do you know? Is since you know this is bigger, what is above it is y, right? Y is at which side? This is your y, right? Is this your what, vertical or horizontal when you look at your y? That is your vertical. So in this case, your answer will be true here. Okay. So this is how you figure out your ellipses having a major axis is vertical or horizontal. You look at who is bigger and look above it. If that is y, it's vertical. If it's this number is bigger than that, then x will be your, which is horizontal. So for question 9B, your answer is true. You guys all right? Questions you have for me? It's a bit. All right, so I'm gonna give you some 4.4. So 4.4 is similar to 4.3. The only difference here is that your center and your vertices is no longer at 0, 0. So in 4.3, all your centers is at 0, 0 at the origin. But now your center is no longer at 0, 0, it's in HK. So what is the difference between the formula for this 4.4 and 4.3 is all your x has to be subtract h and all your y has to be subtract k. That's it. Because your center is HK, so you just need to subtract them, not add. So don't forget, if I give you this, if I'll ask you for center, don't give me negative h and negative k. If I ask for center, make sure you reverse the sign. So if it's a negative, become positive. If this is a plus, then it's a negative. Same thing happens to ellipse. it gives us the same formula, but again, it's minus h and minus k involved with x and y. That means that your center is no longer at 0, 0, it's hk. It's been what we call as translate, means move around. For your hyperbola, it's the same thing. You just need to move your x minus h and y minus k. So what happens now is that because you move things around, everything is the same. Your A is the same thing, meaning center to vertex. Everything have the same meaning of it. The only difference here is that your asymptotes has to change too, because last time your asymptote here is just using y and x. So what do you do here is you just change that. Now since y, you have to subtract k, so you just put minus k here, and your x will be subtract by h. So this is how you figure out your asymptotes for your hyperbola when the transverse axis is at the horizontal. And same thing with this one. We just again put y minus k, and then x minus h. So it's very similar of what you did on the last section. It's just because it's been translated to a point hk instead of 0, 0. So you just need to translate your x and y value to h and k form in this case. And your parabola used to be a vertex of hk, used to be at 0, 0 on last section. We just again translate this to minus h and minus k. And since you translate this, your focus point and your directrix will be translated into here. Okay, so so this is your four conic section. So how do you differentiate between this? This is what should I tell my students. So first thing first, you look at the equation. Okay, how do we know it's circle, ellipse, or hyperbola? And then after you figure it's horizontal, vertical. So if you only have x squared or y squared, that means not both, just the other one is power 1, but the x or y, you will get yourself a parabola. Okay. If you got x squared and y squared together, you need to look at the sign. If the sign both are positive, that means x is positive, y is positive, then you will get either an ellipse or a circle, depending on your A and B. If your A is greater than B, you will get ellipse. If your A is exactly the same as B, you'll get yourself a circle. And if you have x squared and y squared, but this time they are not both positive, you got one is positive and one is negative, it's both positive, then you will get yourself an hyperbola. And in this case, it doesn't matter. The only thing is A has to be greater than 0 and B has to be greater than 0. So this is the only restriction on this. It doesn't have the restriction of the ellipse and circle in this case. So by sometimes once you look at the equation, you can tell me already, is this, what kind of conic is this? So can someone tell me what kind of conic is the first example?
Parabola.
Parabola, because it's square here. Can someone tell me what is the conic for the second example?
Good.
So it can be ellipse and it can be circle because both of them are square with a positive. But we know 9 and 4, your A and B is not the same, right? So this is going to be an ellipse. Okay. How about number 3? Anyone know what this is? Is that a parabola, ellipse, circle, or hyperbola for number 3?
Hyperbola.
This one is a hyperbola because both of them are square and one of them is positive and one of them is negative. How about number 4?
Circle.
It can be circle, it can be ellipse because we doesn't know we doesn't know what is your A and B yet. So that's why we cannot. So you can tell by just looking at it. But don't forget, every time when you give me a parabola or an ellipse or hyperbola, you also need to tell me, are they having a horizontal or a vertical axis? You guys with me here? So in the test, you tell me, oh, this is parabola. So you have to tell me the parabola is vertical or horizontal like this. Now, if they are nicely factor for you, this is called factor because it's all nicely been square. then you can use the formula and you just compare it. But what happens if, like question 3 and 4, do they factor it for you? No. So like this 3, 4, 5, 6, you find out that those questions are not factorable, like what we did see in 1 and 2. So if this is not factor for you, then you have to perform completing the square. Yeah, so this is another, so this is 4.4. Yes, this is what you will get in my test. For test 2, you will get something like this, not something like that. Okay. So if it's not factor, you have to factor it. So you have to do what we call as completing the square. There's no shortcut to do this. So what is the first thing you do when we talk about completing the square is, first, you have to separate your variables. So you gather all your X variable on this side and kind of like break it down, Y variable on that side, and then you put the number on the other side. So we kind of like separate them. And then second, if you have a leading coefficient on your X square or Y square, depends, sometimes you have both, sometimes you have one, you have to get rid of it. And how do we get rid of this is you have to factor the number out. Okay, so this is your second step is, so once you separate, you have any number in front, you have to factor it. Third, inside this box, inside the parentheses, you get a bx here, or by, depends on the y and x axis. What you need to do in this case is you have to take this term, b term, divided by 2, and you square it. This number will be added to him. You have to do it twice, but like equations, if you add a number here, you also need to add this number here, okay, twice, because one is for your X variables and one is for the Y variables, because you got 2 variables, so X and Y, okay. Moreover, because that is, if you factor A out here, you have to multiply it. So that means that this A variable that you see here will also trigger this multiplication. So that means you have to distribute this. So let's say you get this is 9. So if you factor 2 out, you're not adding 9 here, you're adding 2 times 9, which is 18. Okay. And then the fourth step in this case is this parenthesis that you have here will be factor. This one will be a factor, and your factor will be look something like this. Same thing with your Y variable. And then the last one is you add all these numbers up, then you divide by it, because you want to make it equal to 1. And when you divide by this number, make sure that every single one of this is divided, like what we did in the previous example. Remember, like what we did in like this. This is 36, so I had to divide everything by 36 to make this as 1. So this is the same thing here. So the last step is to make your number at the end is equal to 1. Then you can figure out what is your AB in this case. Okay. So these are the 5 steps of doing what we call as completing the square. Okay, it's fixed. You cannot change this. So, and I will show you how to do this. So as you know that we are concentrating more on question 3, 4, 5, 6 here, because this is the one that you get in my test. But I'll just bring out that what do you do here is, first you have to identify the conics. Conics means for this parabola, ellipse, circle, hyperbola, and also for ellipse, hyperbola, and parabola, you need to tell me which axis it goes to, the vertical one or the horizontal one. And then you have to find the vertices, foci, center of the conic section. For that means you have to tell me what is the focus point, the directrix, if it's a parabola, vertices, foci, and if it's a hyperbola, you tell me your asymptotes, and you have to graph this. So this is a lot of work here. Okay, this is a lot of work. This is not something that and yes, in the test, this is the big point in your test number 2. This kind of questions will worth around, let's say like 10 to 12 points. Remember when you, on your first test, you have to graph the rational function, you have to do A, B, C, D, E, all the smoothies. This will be the same thing as this. Okay, so let's take a look at question 3. So please concentrate on this type. And once you know how to do this, 1 and 2 is easy. Okay, so when you do your homework, the first 2 questions like this is easy because you do not need to do any factoring. But once you get into here, you will need to do some work. So first, we need to perform what we call as completing the square. So first step in completing the square is gather around the variables. So separate them. So the x's, so we got 4x squared minus 4x. So I gather that in left side. The y squared, don't forget the negative. You need the negative y squared, you put it in the middle here. And you move that -3 over there, so it become positive. So this is your first step to do this completing the square, is to separate your x, put your y in the middle, and put your number term at the back. Next thing is, this is the first step. Let's do the x variables. The y variables, you do not do any work because it's only one term. So once you get 2 terms like this x variables, you begin to do all the 5 steps that I showed to you. But if you only got y squared here, leave it. There's nothing you can do. So since you got a, which is 4, so the second step is you have to factor the 4 out. And when you factor the 4 out, you get x squared minus x. So this is your second step. Means if you have a leading coefficient on the x squared or y squared, you have to factor it out. And then the third step is to take your middle term b, which in this case is 1. You will need to divide this by 2 and square it. That number is 1/4. So what you do in this case is you will add this number to here, the 1/4. And you also have to add it to this side, your equation. Because it's an equation, you have to balance it. So when you add a 4th here, now you don't add a 4th here in here. This is wrong because of the 4 that you have early on. So what number should we add here to really balance this equation?
1.
1, because 4 times 1/4 is 1. Okay. And so this is your step number 3, is where you take the middle term, divide by 2 and square it, and then add it to both sides. And then watch for this term, you have to distribute your a into it. The third steps. 4th step is you take this 2 and you factor it. And that factor is a perfect square. That's why we call it completing the square. The 4 is still there. This one you figure out by taking x, and then you got the minus, and then you take the half or square root of this. So the negative and plus is determined by the sign here. So if this is a minus, then it'll be minus. If this is plus, it's plus. Square of 1 is 1. Square of 4 is 2. Or you can use 1/2 here. So when you FOIL x minus 1/2 squared, you will get back x squared minus x plus 1/4. So this is your 4th step. We call it as factoring. We will do this on your y, but your y is only by itself. So actually you do not need to do anything on the y. So this is y squared. If this is y squared plus 6y, then yes, you will do the same, repeat the same step. But since we don't have any terms next to it, this is it. And you just need to add these numbers out to give it to me, and that will be 4. So this is step number 4. The last step is to make it equals to 1. So I will divide everything here by 4. So you get 1. And this 4 and 4 will cancel out. So what you get is x minus 1/2 squared. And if you want, you can make it over 1. I'm not picky. And then y squared over 4. So this is the equations that you will use to figure out your conic section. So once you get this equation, you just need to look at your formulas here and to compare which one is the same as this. So can someone tell me which one is this one, the conic section?
hyperbola.
And don't forget, if you tell me it's a hyperbola, can you tell me also which one is that? Is that a horizontal one or the vertical one?
Horizontal.
Horizontal.
Because your x is positive, so which is very similar to this one. So this is actually is the horizontal one. Okay, so it's a hyperbola with a horizontal. So next is you need to tell me the center. Okay, so the center in this case is HK, which is this is your H and that is your K. So what is your HK in this case? H is 1/2. K is 0 because there's no adding subtracting. So this is how you figure out your HK, your center, 1/2 and 0. And also if you look at your hyperbola, you get yourself, this is your A square and this is your B square. Okay, because A square is underneath the X and B in this case, in this equation or formula. So now we can take this A square and B square and you're just looking at your A. So in this case, what is A in this case? Take the square of it, so you get plus minus 1. B is plus minus 2 because 4 is perfect square of 2. Now you need to figure out C. And how do you figure out C in this case is you have to use your formula. Since it's a hyperbola, the formula is this formula to find C. If it's an ellipse, you will use the minus sign. So in order for us to find C in this case, you have to use A squared plus B squared. Exactly the same as your Pythagorean theorem. So C squared is A squared is 1, so 1 squared is 1. B squared is 2, so B is 2, so square become 4. So in this case, C will be plus minus square root of 5. So this is how you figure out, these are worth points. When you do it here, they're all worth points. The next thing we're going to talk about is your vertices. Okay. Now, since you tell me it's a horizontal, so horizontal means if you draw the graph, everything is going to be on the horizontal line. Horizontal is X. Okay. So so that means your X in this case will be, if you want to find your vertices will be H plus minus AK. The reason why is because when you have a horizontal, everything is on the x-axis. So that means your x-axis will be added plus minus a. Okay. In order for you to find the foci in this case is going to be the same, but instead of A, we use C. The C is for foci. This is for horizontal, and this is for hyperbola, ellipse, or parabola. If you want to figure out your horizontal, always the number that you find here will be added to your x. But if this is a vertical, then your plus minus AC will go to your k. That means it'll be HK plus minus A or plus minus C. So this is how you find your vertices and your foci for this case. So let's look at your vertices here. So H in this case is 1/2 plus minus 1 because A is 1, 0. Now again, do not leave your answer like this because you can actually add them up. So 1/2 plus 1 and 1/2 minus 1. So 1/2 plus 1 is 3/2, 0. And 1/2 minus 1 is -1/2, 0. So in your homework and in my test, don't give me this, you won't get full points. The reason why is because you can add those numbers up. And in your online homework, they ask you for the big and the small. So this will be the maximum of big one, and this will be the small one because negative. For your foci, you just do the same thing, is 1/2 plus minus c. But unfortunately, c in this case is √5. So this case, you cannot add them up. The reason why is because the square root. If you have any square root numbers, when you add them up, it's all a bunch of decimals. So your answer in this case will be 1/2 plus √5 0 and 1/2 minus √5 0. Same thing in your online homework. They don't like plus minus, so you have to write it twice. One is plus, one is minus. And the reason why you cannot combine these two up is because of square roots. Okay, so we got the conic sections, we got the center, we got the ABC here, we got the vertex and foci, and horizontal has one more extra stuff, is your asymptotes, which is y equals to plus minus something over something x. This is the same thing like what we did last time. So can someone tell me, if you're looking at this formula, is that A over B or B over A?
B over A.
Looking at your y, because your y is B, so it's B over A. What you need to do extra here is you just put an x minus h here and y minus k here, because now we translate it. You just need to put that down. So what we have is k is 0, so we have nothing here. So it's y equals to plus minus a, b over a. B is 2, a is 1, so 2 over 1 is 2. And then x minus h. H in this case is 1/2, because you got the 1/2. Now in my homework, you just leave it like this. You do not need to distribute the 2 and do all this work. But in your online home, this is my test. You just leave it like this. But in your online homework, you have to distribute your 2's and stuff like that. So you have to. So in your online homework, they don't like plus minus. So you have to do it twice. One is a positive, one is negative. So if you distribute your positive 2, you will get 2x minus 1. And then if you distribute your negative 2, you get negative 2x plus 1. So this is just for your online homework. Okay, so you just need to distribute your 2 and a negative 2. And let's say this is a minus 3 here, then after you have to add 3 to that side, like solving for y when you do your equation. So this is just for your online homework. Okay, so all this worth points. This is cost around, like, again, big points, 12, 13 points here. And now we need to draw your graph here. So your graph, you do not need to worry about C. Okay, same thing with ellipses and same thing with hyperbola. You don't need to worry. You just need to worry about your A and B. And hyperbola, you need to give me the box, like what we did today. So A is 1, since you tell me it's working horizontal. Horizontal is A. So that means your A in this case, which is your vertex, will be, oh, not there, not there, not there, not there, not there, sorry. My bad, not over there. Because your center is 1/2 0. So 1/2 0 means 1/2 0. So it's right here because you move everything to the right 1/2. So this is your center. Okay, 1/2 0. We use the color coded here. So vertex, you will do 3/2 and negative 1/2. So 3/2 is here. So this is your vertex. And negative 1/2 is here. This is your vertex. So this is your center. The blue one is your center. The red one is your vertices. Now we're gonna draw the box. So in order for you to draw the box, the vertices we know is 1/2. So that means you go 1 to the right, 1 to the left. Your B in this case is 2, means you go up 2 and go down 2. So follow the center. So the center is the one that determines your middle part. So you go up 2 here and you go down 2 here. So this is your B and this is your A. So center is always the main part. And you draw me that box. So that box is where you will cross at the center and the V. So this is your box. And now what you need to do is draw me the X. The X is always will cross the endpoint to the center is here, sorry, the 0. So this is your asymptotes here. So it will cross at the, again, please use a ruler because I don't have a ruler and this is just a freehand. So it's a little bit hard to draw. So this is your asymptotes. And since this is your vertex and you tell me it's horizontal means it open sideways like this. So your graph for this case will be just doing, make sure you cross the vertex here. Oops, sorry. And it goes like pretty parallel to this, parallel to the asymptotes. Cross over here. So this is how you draw this hyperbola. Lots of work, huh? And it's not easy. I didn't say this is easy. This is a bit difficult. Any questions? Lots of practice. Yeah, you need to practice. I'm sorry, Nuki.
Oh yeah, how did you, at the very top, it says 1/2 squared. Where'd you get the 1/2 from?
It's taking the, this is taking the half of this. You see the 1/2? Or you take the square root of this from it.
Okay, then where did the 1/4 come from?
1/4 is where you square both sides. So you take 1/2 and you square, you get a quarter. So that's 1/4 comes from. So the rule says that the third step is you take the middle term and you half it and you square it, and that's the quarter come from. Some
Wait,
stuff here.
Half of the x is 1/4.
No, you square the half. So the formula says, this is again completing the square. What is completing the square says is you take the b, you divide it by 2 and you square it. So our b in this case is 1. And you square it, is a quarter, and you have to add this quarter to both sides of this equation.
Oh, okay, got it.
So
Yeah.
again, I will show you some more example because you're just doing one example. So you have, I'll show you, this is, yeah, you get more examples. It's attendance. Please, can you put attendance sign? Yeah, you will see a lot more examples. Again, brush up your completing the square. So if you doesn't know, this is called completing the square. So go to YouTube. This is not in this class. This is in your algebra 2 class. So brush it up. Yep, there is a completing the square part. So question 4 here, long equations. So first thing you need to do here is again separate all your variable x, y, and then numbers. So the x we have is 16x squared minus 16x. The y here is, don't forget, you need the plus. So a lot of students forget to put the plus sign on the y square. So make sure you put the plus sign. And you got the 24y. This is the first step. And then again, we got the 3 on the corner here. So you move the 3 on the side. So this is your first step. Second step, you have to take your factor out. So now I'm going to do the x. You're going to do the y for me. So 16, you can factor out the 16 here. So you will get x squared minus 1x. And what do we need to do is the same thing. You take the middle term over by 2, always over 2, and always square it. And that will be 1/4. So this is how I get my quarter from. But when I add it to this side, you cannot add a quarter because you have the 16 in front. So you have to multiply this by 16. Can someone tell me what is 16 times a quarter?
4.
4. Yep. So you had to add 4 here. Okay. And this is step number 3, where you factor the 16 and then add 1. Then what you do next is you have to factor this below. And the factor for this is x minus 1/2. Again, where is the 1/2 come from? It's the square root of 1/4. And I still have a 16 in front. So this is how we do completing the squares. So can someone tell me what the y you have to do the same thing? So can someone tell me what can you factor? Now, a lot of students think like, oh, the common factor between 16 and 24 is 8, right? So I factored the 8 out. My answer to you is we don't do the common factor. We do the whole 16. Okay. Our main goal here, when you perform completing the square, is this has to be 1. So this is why it always works this way, as long as your leading coefficient is 1. So you don't factor the common, the greatest common factor. Oh, 8 goes in there. No, you factor 16. Can someone tell me what happens when you factor 16 out from 24? You will get 24 over 16. Because the 16 and 16 will cancel, you get 24. But can someone reduce 24 over 16?
3/2.
This is 3/2. Now, we need to figure out what we need to do here, the purple one. So what do we do here is you have to take the b term. Last time is 1. Now it's not 1. Now it's 3/2. So you take 3/2 divided by 2 and square it. So this is for the y term here. You're gonna add this below here. So always the middle term, always divided by 2, always square. So what is 3/2 divided by 2 is? Anyone know what 3/2 divided by 2? This is 3/4. So if you have a fraction and you divide by a number, what you do here is you just take this 2 denominator and you multiply it, which is 4. So that's why you got 3/4. What is 3/4 when you square it? This will be 9/16. So you will add 9/16 here. Usually we add 9/16 on the other side to balance the equation, but you don't add 9/16. What do you add here? 9/16 times what? What we have factored early on? A 16. So you multiply that by 16. Does anyone know what is 9/16 times 16 is?
9.
9, yes. So you add 9 here to balance the y variable, the y term. So now we have to factor this fellow. So the factor is always square. So you have the y here. We have a plus because it is a plus. Last time is minus. Can someone tell me what is the perfect square of 9/16? Nine is a perfect square of
3/4.
3/4, yeah. And don't forget, we still have a 16 over outside and the plus. And now what you need to do is add all these numbers up on the right side here. So what is 3 plus 4 plus 9?
16.
16, yes. And what we need to do next is, because we want to make this 16 as 1, so I will divide everything by 16. You know what happens when you divide everything by 16? This will cancel out. This will cancel out. So what you get here? X minus half square plus y plus 3/4 square equals to what?
1.
1. Class, if you look at this and compare this equation, the blue one that we just did, and compare this with your conic section, what conic section is this? Is that going to be a circle, ellipse, parabola, hyperbola? Which one is the one that looks like him?
Ellipse.
Ellipse only happens when A is greater than B, right? But what is your A and B in this case?
1.
1 and 1. Do you know what happens if your A and B is the same? We don't call that as an ellipse anymore. What we call that?
Circle.
This is a circle, yes. So this is a difference between an ellipse and circle is ellipse, you have A and B on the bottom. That means A has to be bigger than B, but circle, they have the same. So circle, you need to know two things. So in circle, you just need to figure out what is the center of the circle and what is the radius of the circle. So center of circle is given us by HK. So this will be your H and this will be your K. So can someone tell me what is your center of this circle? H is negative or positive 1/2.
Positive 1/2,
And K in this case?
negative 3/4.
Yep. As I tell you, you switch your sign for HK. Radius comes from the number here. So if you remember the formula, this last number is radius r squared. So in order for us to figure out the radius, you take the square root of it. Can someone tell me what is radius in this case? It will be just 1. Okay. So now, so that's it. That is what you need to figure out for circle. So if your conic section is a circle, you just need to figure out the center and the radius. You just do your no asymptotes, no vertices, no foci, no all those things. So now you need to draw it. So I'm going to draw a little bit bigger because this is a very small scale. So I put half scales in this case, so it'll be nicer. So just, so the center is 1/2 negative 3/4. 1/2 is here, negative 3/4 is here. So this dot is your center. Okay, somewhere this is 3/4, somewhere half there. You say your radius is 1. So if you look at this unit, there are 2 units to make 1. So what you do here is you make 2 units, 1, 2 units, because that will be the radius is 1. And then you make 2 units, 1, 2 units right here, because this is a half of it. So this 3/4. And then you do 1, 2 units. This is your other circles. And then you go down 1, 2 units. So that means that the radius here is all 1. And it's very nice if you use a graph paper and circle, then draw me the circle. Again, this is a really bad circle. So no graph paper, that's why. So make sure that when you draw me the circle, first tell me where the center is, and then figure out 1 unit to the right, because your radius is 1, 1 unit up, 1 unit to the left, and 1 unit down. You kind of like drawing a cross here, up, down, left, right, and then you draw me a circle. So this is a circle, and this is the answer to do question 4, which is not a lot of work, but what I want you guys to practice is how you perform what? Completing the square here. So this is the major points in this case. So I think our time is up here. So I really want you guys to look at my notes. I think you can find my notes in D2L and try to do 5 and 6, because again, this is the same thing as what we did so far. I will continue this in class on Monday. So this is the one that I will spend a bit more time in the class on Monday. So make sure you guys know how to completing the squares here. Because again, the reason I spend a bit more time on this is because this is in your test and this is the most points, like 12 or 13 points in one question. And you only get 1 of these in your test. So I won't give you like 4. Okay. So practice this. Again, look at my notes. It's in D2L. It will tell you how to do it. And I will go through some of these questions here, okay, to end 4.4. Anyone have any questions for me before we end our Zoom today. If you don't have any questions, you may leave. If you have questions, please stay back and you can ask me any questions. No homework due tonight. Homework is due next Wednesday, 4.3 and 4.4.